Hi friends, welcome to Answers. So today it is the 68th episode in the science series. So in science today it is physics. So today we are going to discuss about the electromagnetic spectrum. Yes. So you may ask before, but you already discussed about light before in another video. So electromagnetic spectrum, it is just light. It is just light, but in all of its types. Yes. So just think of this video as a light part 2 in the series. Yes. So here we have the electromagnetic spectrum. All of the types of waves it has, which are pretty much a lot of them. Yes. So first, what is an electromagnetic wave and what makes it different from any other wave? So first, let's draw a normal wave. So a normal wave is known as a mechanical wave. This is a mechanical wave. Yes, but then let's take the electromagnetic wave. The electromagnetic waves are not one wave but two separate different waves. So this is the those are the electric wave and the electric field and the magnetic field. Both of them just work together to form this electromagnetic radiation. So think of this as the electric field, and then how to draw this? Yeah, it goes like this. They both go pair to pair. Yes, just like brothers. Okay, so this is what normally electromagnetic waves look like. Yes. So then let's see all of the types of electromagnetic radiation. So the types of electromagnetic radiation are, so first the largest are radio waves, next microwaves, next infrared, and then the visible light, which is literally the smallest part of all of the spectrum. See how small this thing is. Then there is ultraviolet, then there is X-ray, and finally there is the gamma rays. Yes. So here it is a symbol for gamma in Greek, not to be confused with Y. Yes. So first let's explain these things here. Why did I draw these numbers? So these numbers are the meters. So these waves, normally you think of them as very small. Literally the visible light spectrum is just like in 700 nanometers like that. It's very, very small. But radio waves, they are humongous. They are larger than literal kilometers. Yes, their waves, they are larger than this. Yes, meanwhile the smallest of waves are just this much. Yes. So yeah. So let's start with the radio waves. So these radio waves are just the waves, you may remember them from your car radio. So these transfer radio. So these radio waves help do what these electronic radios do. The device radio. Yes. So the radio does this by, so first after a radio center just makes something, tell something about blah blah blah, say them like that. So after that, if another radio has a perfect frequency with that radio station, then those radio waves which were just going all over the place will be attracted into that the radio device. After they go into the radio, then they will become changed into mechanical waves, which are sound waves, and then we can hear what the radio person could say. Yes. So this is the use of radio waves. So radio waves are also used in Wi-Fi, radars, TVs, and lot of other things, many other mobile applications. So next are microwaves. Yes, those same microwaves. The microwaves which literally heat your food. So yeah. So we normally use them inside microwaves, right? But these also have many other uses. So because of microwaves, we mapped out the whole observable universe. So what happened is, when the Big Bang happened, after many years, when it was just chilling, so the universe sent out a very large explosion of microwaves around what we can see presently. Yes. So in the present day, the scientists mapped all of these microwaves around, and they made a map of the observable universe, approximately like that. Yes. So this is the main use of microwaves. And then there is infrared. Infrared is used in many other things like lasers, all of them. Yes. So it is also used to detect heat. Yes. So next is the visible light. The light which we can normally see. We can't see any other light, just this visible light. And yeah. So next is ultraviolet. So here infrared is just the more extreme version of the red we can see, and ultraviolet is a more extreme version of the normal violet. Yes. So yeah, let's go to violet. So ultraviolet. So first there are two types of waves inside the electromagnetic spectrum, ionizing and non-ionizing. So inside this electromagnetic, ultraviolet is the split between ionizing and non-ionizing. So if a wave is ionizing, so that means it has so much energy when it is going, so because of its very small frequency waves, so it can literally damage the human body or anything it can come in contact with. Yes. So the most extreme version of these ionizing waves is the gamma rays. So this extreme type of ionizing ultraviolet is the one which the sun sends at us to attack us. I hate those type. Meanwhile the other type is pretty safe for us. It doesn't do anything mostly. So next are the X-rays. So these X-rays, they are used in X-ray machines to just see the bones of your body. So they can see this because of, so first there is the body, the human body, who is standing in front of an X-ray camera thing, and behind him he's just like the, what do you call it? The thing which we see the X-ray photos on. Yes, it is back there. Okay. So then the camera takes the photo with X-ray vision. Yes. So the X-ray goes through normal skin, but it can't go to bones because bones are too hard for X-rays. And because of that, we can see the bones or any cracks that happened from an X-ray test. Very simple. Yes. So these are X-rays, but too much exposure to these X-rays can be fatal. And finally, the most worst of them all is the gamma rays. This is the most extreme type of ionizing radiation in the whole world. Yes. So this can literally damage the whole body because of its very large frequency, very small frequency, very high frequency, sorry. Yes. So its waves are very small, literally many times smaller than an whole atom. Yes. So because of this, they create a lot of energy when they are moving like this, and they more act like what do you call them, a laser, because there is literally no distance between the waves themselves. Yes. So they act like a laser. Yes. So when they hit any atoms or any other tissue inside the body, it completely disrupts that region. So because of this, these gamma rays are very dangerous, and also it can warp the DNA, it can damage DNA, helping to create cancer inside the body, which is very bad if you know what cancer is. So yeah, this is for today about the electromagnetic waves. Bye.